Hello friends, this video on Introduction to Trigonometry Part 12 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 to Part 11. Now let's understand what is called trigonometric identity. Equation is called trigonometric identity if it is true. It is true for all values of the variable. So any statement which is true for all the values. For give any value, you give any value of theta. If a particular equation is true, that means it is an identity. So there are three identities. One is cos square a plus sin square a is equal to 1. You give any value of a, 0 degree, 20 degree, 30 degree, 40 degree. This will always be 1. Similarly, 1 plus tan square a is equal to sec square a. This will always be true, and cot square a plus 1 is equal to cosec square a. This statement will also be true always. So these are the three trigonometric identities. Please remember, sin square plus cos square is equal to 1, 1 plus tan square is equal to sec square, cot square plus 1 is equal to cosec square. These are the three trigonometric identities. Very important. Please understand this, please learn this. We'll prove these trigonometric identities in the next. So first we have to prove cos square a plus sin square a is equal to. So let's take this angle A, in this right triangle this is hypotenuse. If we have taken A as the frame of reference, this is base and this is perpendicular. Correct? Cos A, again we use this formula, Pandit Padri Prasad. Hare Hare Bol. This is sin, cos, and this is tan. So cos square A will be equal to B by H square. B by H square. Correct? Similarly, sin square A will be equal to P by H square for any angle theta. So cos square A plus sin square A will be B by H square plus P by H square. This is nothing but B square plus P square by H square. We know that since it is a right triangle, B square plus P square will be equal to H square. Right? Hypotenuse square is equal to base square plus perpendicular square. So this becomes H square by H square, and that is nothing but 1. So we have proved that cos square a plus sin square a is equal to 1. Now let's prove 1 plus tan square a is equal to sec square a. Again, Pandit Badri Prashad. Hare Hare Bol. Sin, cos, tan, cosec, sec and cot. This is the frame of reference. This is H. Since A is the angle we are talking about, my frame of reference, this becomes B and this becomes P. So I'll get 1 plus tan A is nothing but P by B. P square by B square. Right? This is nothing but B square common. Sorry, tan A is P by B. So this is P square. B square common. B square plus P square. Correct? B square plus P square is H square. So this becomes H square by B square. And H by B square is nothing but, if you see, sec square. This sec square A. And that is what we are supposed to prove. So we have proved that 1 plus tan square A, that is P by B square, is equal to sec square. So this is also true for any value of theta. You take any value of theta, this will be 2. Let's take the last identity. Cot square A plus 1 is equal to cosec square A. Again we'll use Pandit Badri Prasad. Hare Hare Bol. This is sin, this is cos, this is tan, this is cosec, this is sec, and this is cot. Since theta is my angle A, this is H, this will be base because the side adjacent, and this is perpendicular. So cot is nothing but this one, b by p square plus 1. This is nothing but b square plus p square by p square, and b square plus p square is nothing but h square in right triangle by Pythagoras theorem by p square. H by p is nothing but, if you see, h by p is nothing but cosec theta, h by p. So this becomes cosec square a, and hence this is true for any value of theta, any value of a. Correct? We have to express the trigonometric ratio cos a, sec a, tan a in terms of sin a. So what we can do? We know the identity sin square a plus cos square a is equal to 1. So with this I can get cos a in terms of sin a. So what will get? Cos square a is nothing but 1 minus sin square a, or I get cos a is equal to root of 1 minus sin square a. So cos a is done. Sec a is nothing but 1 by cos a. This is nothing but 1 by root 1 minus sin square a. So I could write sec a also in terms of sin a. Done. Tan a is nothing but sin a by cos a. Sin a, it's okay because we have tried in terms of sin a only. Cos a I have tried in terms of sin a. I know cos a is equal to root of 1 minus sin square a. Thus I have written tan a also in terms of sin a. Cos a, sec a, tan a, everything is done in terms of sin a. And that is my answer. See, in all these questions, when you are asked to write sec a, cot a in terms of sin a or cos a or tan a, you have to use all the trigonometric identities. Let's take one example. We have to write all the trigonometric ratios in terms of sec a, for example. So first thing we know is cos a is equal to 1 by sec a. That's the easiest thing we know. Correct? So cos a is done. So what we have to do is sin, cos, tan, cosec, sec is anyway is there, cot. All this you have to write. Cos is done. Correct? Sin we know is nothing but root of 1 minus cos square a. The sin square a plus cos square a is 1. So sin a is nothing but root of 1 minus cos square a. Cos I have already written in terms of sec a. So I write this is nothing but 1 minus 1 by sec a square. If I have sin and cos, I have everything actually. See, sin and cos I have in terms of sec a. Tan a is nothing but sin a by cos a. Or tan a is also sec square a minus 1. Direct formula. We can either say tan a is equal to sin a by cos a. Sin a is in the term of sec a. Cos a is in the term of sec a. I can do that. Or I can say sec square a, tan a is equal to root sec square a minus 1. Directly I have used the relation. Cot a will be reverse of tan a. That is 1 by tan a. Correct? Since tan a I have already written in the terms of sec square a, is nothing but 1 by root of sec square a minus 1. Done. Cosec a is nothing but 1 by sin a, and this is nothing but sin a is this one. This is nothing but, if you solve this further, this comes out to be sec square a by sec square a minus 1. And this is nothing but root of sec square a minus 1 by sec a. So cosec is 1 by sin a. This will become sec a by root of sec square a minus 1. So if you see, I got all the trigonometric ratio in term of sec a. What I have done, cos a I found sin a, and then I can find anything. We'll try this example. Sin square 63 plus sin square 27 by cos square 17 by cos square 73. This is example where we convert sine to cos or cos to sine. So let's convert everything to cos now in this case. Sine 63 I can write as nothing but sine of 90 degree minus 17 degree square plus sine square 27 also I can write something as 90 degree minus this will be 63 by this will become cos of 17 plus cos square 73. So if you see this would get cancelled. Why? Because this becomes cos 17, this cos 17 cancel, but this is not getting cancelled, so this approach won't work. Let's think once again. If you see 63 plus 27 is equal to 90, 17 plus 73 is equal to 97. This plus this is not 90, this plus is also not 90, this is not forming a pair, but 63 plus 27 is forming a pair and this plus this is forming a pair. So what we can do, so if I can convert this into cos square, so this becomes sine square 63, this becomes cos square 63, sine square plus cos square is equal to 1. Here also this cos, if I can convert this into sine, it will be cos square x plus sine square x will be 1. Because this and this is forming a pair. So let's do this way. This becomes sine square 63 plus sine square 90 minus 27 by cos square 17 plus cos square 90 degree minus 17 degree, 90 minus 63 actually. Why? Because this is forming a pair, 90, 63 and 27. So this comes out to be sine square 63 plus cos square 63 by cos square 17 by sine square 17. Sine square theta plus cos square theta is equal to 1. Cos square theta plus sine square theta is equal to 1. So 1 by 1 is equal to 1 and that is math. Earlier we tried to convert the numerator to cos, but that didn't work out. So then we observe that 63 plus 27 is equal to 90 and 17 plus 73 is equal to 90. So these are forming a pair. So we converted this sine to cos and this cos to sine. And we got sine square theta plus cos square theta pattern. And that became 1. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.